Okay, so as we're getting ready for exam week next week, remember exams are 27, 28, 29th of January, so that'd be like the Wednesday, Thursday, Friday of those weeks. Um, you're supposed to take it according to like your schedule, your first or second hour, third or fourth, fifth or sixth on those days. We'll give you more on the schedule later on there. Uh, the One of the most missed questions on the exams, always, and even the quizzes, the tests we've had this year, is anything involving quadratic formula. So I wanted to just kind of go through the simplifying the steps a couple more times here, just so you see it again. There will be a formula page that you can have open while you're working on the exam, so that it'll be in your classroom and everything like that. So if you are taking it online, that'll be available for you. Now, the quadratic formula, if you want to just jot it down real quick, is negative b plus or minus square root of b squared minus 4ac all over 2a. And our a, b, and our c are just our coefficients on each of these variables in descending order here. So the first step's going to be substitute everything in. So it's always the opposite of b. So in this case, it's going to be a positive 7 root the negative 7 squared minus 4. A is 2. C is 4. All over 2a, which is a 2 in this case. So that's what we need to simplify. So we're just going to work that out and see how things kind of shake out here. So under my root, I'm going to have 49. Remember, this is always going to be positive because you're squaring a number. Anytime you don't multiply a number by itself, it's going to be positive. So if you're using a calculator, which is perfectly fine, use your calculator correctly. So what I mean by that is, if you do this, you are not using your calculator correctly, because this is going to square the 7 and then make the answer negative. That's not what we're doing here. You want to enter it as this, which has been a thing all year long. Definitely not something new there. But also, just conceptually, you should know that if I'm multiplying a number by itself, it's going to become positive every time. Okay. 4 times 2 is 8. Times 4 is 32. So we're taking away 32 over 4. I'm just going to kind of keep working over here so I don't lose space. So what do I have? 7 plus or minus. Now, under my root, 49 minus 32 is going to be 17, which in this case is a prime number. 17 doesn't have any factors. And more specifically, it doesn't have any perfect square factors. So like 4 or 9 or 25 or 36. None of those go into this. So this is a case where this is actually as simplified as it can possibly get, because we can't divide the 7 or the 1 here by 4. Those don't divide or reduce evenly. So really, this one is a pretty simple version that you just simplify it as much as you can, and then you stop there. Now, sometimes this root can break down further. Sometimes it can't. Sometimes you'll get an imaginary value under here if this is negative. So let's go ahead and look at the next one so we see some of that stuff in action. So same process, we got a quadratic equation here. Let's go ahead and get to it. So opposite of b plus or minus b squared minus 4, a is negative 1, c is negative 8, all over 2 times negative 1. Cool. Okay, so let's see how we go here. So we're going to get 9 because 3 squared is 9. This overall is going to be negative because you got negative, negative, negative. So 3 of them makes a negative. 4 times 1 is 4 times 8 is going to be 32 again. And we're over negative 2. Okay. So under our root there, 9 minus 32 is going to be a negative number, specifically negative 23. Okay. Now, again, we get a number that happens to be prime. So 23. 23 has no perfect square factors. Nothing goes into it. So in this case, when we get to simplifying it out, we're going to have negative 3 plus or minus. The only thing we want to pull out of here is the square root of the negative here, because technically you can break this up to like negative 1 and 23. So the negative always is going to give you an imaginary value, and then we just can leave the 23 under the root, like so. And once again, we can't, there's the negative 3 and the 1 that are here don't divide evenly by the negative 2, so we're just going to leave it as that. So I did 2 examples here where we don't have any simplifying of the root. Okay, other than, in this case, we were able to pull the negative out as an I, which we definitely want to do. Now, the other scenario here that you want to be on the lookout for is, let's just pretend when you did this, it wasn't a prime number. So obviously this is the answer to this problem, but let's just say you were doing this and maybe you ended up with something that looked like this. Maybe under your root was negative 80. Okay, so let's say same everything except this happened to work out to be negative 80. All right, now this is one you definitely need to break down. So you got to look at 80 and you got to say, okay, what's a perfect square that can go into 80? And when I say perfect squares, we're talking like, does it divide by 4? Which it does. Does it divide by 9? Nope. Does it divide by 16? Yes, it does. Does it divide by 25? No. Does it divide by 36? No. Anything above that's not going to work either. But we always want the biggest one. So 16 is the biggest perfect square that goes into this. So here's what I'm going to do. I'm going to break it up. And I'm going to rewrite it as basically all the parts that multiply to give me this, which is going to be 16. I'm going to pull the -1 separately, and then I'm going to pull the 5 separately. So if you multiply these three numbers together, they give you -80. But we're breaking it up in such a way that now we have something that's a perfect square, the I, and this part's going to just remain under the root. So our overall answer here is going to be 4i, because the square root of 16 is 4, the square root of -1 is I, and then the root 5 remains. So now we get something like this. And again, 3 and 4 don't divide evenly by 2, so we can't go any further. Now, if this was like 4 and 4, and those are both divisible by 2, then we could do that, and it would just become -2 plus or minus 2i root 5. Okay? So we've seen that on quite a few things, but just to kind of recap everything. So again, this is not the answer to this problem. This is just an example of what you do if your root was something you could break down. Okay, so kind of a lot of stuff there, but this is one of these concepts that doesn't go away. We've used it since chapter 2. We will keep using it going forward into semester 2.